In this video, I'm going to discuss problem number C from today's Code Forces contest. So this problem was quite easy in comparison to other division 2 problem number C. So let's understand what the problem statement is. So basically, uh, you are a game designer and you want to make an obstacle course. The player will walk from left to right. You have n heights of mountains already selected and want to arrange them so that the absolute difference of heights of the first and last mountain is as small as possible. Alright. In addition, you want to make the game difficult. Now, since walking uphill or flat is harder than walking downhill, the difficulty of level will be the number of mountains I such that hi is less than equal to hi plus 1, where hi is the height of ith mountain. Now you don't want to waste any of the mountains you model, so you have to use all of them. From all the arrangements that minimize absolute value of h1 minus hn, find one that is most difficult. If there are multiple orders that satisfy these requirements, you may find anyone. All right. So basically, you are given an array and you have to arrange that array in such a way that the difference between first and last character is as minimum as possible. And the second condition, which it should meet, that among all such arrangements in which the difference between first and last character is as minimum as possible is minimum, you have to find the one in which you can find the maximum difficulty. So difficulty is given by this. So whenever the character, the height or the element at ith position is smaller than or equal to height or element at I plus 1th position, then you can count it as one hard level. So you have to keep maximum such configuration in the arrangement in which the hi, h1 and hn difference is minimum. So this is a very simple problem. For getting the minimum difference, what you can do is you can sort the array. So after sorting your array, let's take example of this one. After sorting your array, you will have 1, 2, 2, 4. Okay, let's take a little bit a larger example. So 1, 2, 2, 3, 3, 4, 5, 6. Okay, so suppose this is what you have after what you get after sorting. So you can compare these adjacent elements. You can iterate from your I equal to 1 to n, and you can compare I minus 1 and ith position element. So you have, since you have to keep the difference between first and last element equal, so you need this first and last element to be as close as possible. So if they are same, then the difference is 0. You can't minimize difference more than that. So here you can find 2, 2. Since this difference of these two is 0, the another combination of first and last which you can get is 3, 3. In that case also the difference between first and last would be minimized. So let's suppose we took 2, 2. So in that case, at first position you will put 2, at last position you will put 2. So in between you have to fill the rest of elements such that hi is less than equal to hi plus 1. This condition is as maximum as possible. So for 2 you can keep all elements greater than equal to 2 first. So if you will put 3, 3, 4, 5, 6. So for all these elements, you can see this hi is less than equal to hi plus 1 will meet. After this, you can put all elements smaller than 1 in sorted order. Here we just have 1. So for this portion also, this condition will be met. So this is the best possible combination you can get. The answer for this is, you can see this 1, 2, here also hi less than equal to hi plus 1. So 3, here 4, 5, and here 6. So hardness is, you can see 6, and difference between h1 and hn is minimum. The second combination, if you choose to put 3 at starting and ending position, then also you can put this 3 at starting and ending position, such that h1 and hn difference will be minimum, which is 0. And again, you can put all the elements coming after. Suppose this is your x, the first one, and this is y, such that the difference between x and y is minimum. So you can put all elements greater than y over here. So you can put 4, 5, 6 in this order, such that you will get this hi less than equal to hi plus 1 for all these. And after that, for the rest part, to get hi less than equal to h1, you can put all elements smaller than x in same increasing order, 1, 2, 2. So here also you can see this one, and this one is satisfying the condition of h1, hi less than equal to hi plus 1. So here also the hardness level is 1, 2, 3, 4, 5, 6. So it doesn't matter which two of the elements you choose. So what you have to do, basically, you have to just iterate in the array and find two element x and y. X and y will always be adjacent, such that the difference is minimized. So once you finish one iteration, you will have two elements position. One is x and another is y. So at the 0th position, you can keep your x. At the last position, you can keep your y, or vice versa, whatever. So after the first one, you can put all these elements coming after y, and after that, you can keep all elements coming before x in increasing order, and you will finally have your solution. Okay, now let's see the code for this question. Okay, so here you can see we are getting this n. After we are getting this array of size n, I'm sorting this array. I'm initializing difference with the difference of 0th and first one, and I'm initializing my x and y, which is index of two elements, which will come at first and last as 0 and 1. I'm iterating from 2 to n, and I'm checking if difference of vi and vi minus 1 is less than current difference. I'm updating my difference, and I'm updating index of these two elements as well, x and y. After this loop will get finished, we will finally have x and y in our hand, which are the two elements which we are going to put at first and last position. So at first position, we are putting x, and then for I'm putting all elements coming after y in increasing manner. Since our v is sorted, vector v is sorted, we are just printing all those. After that, we are printing all elements which are coming before x, and then we are printing our last element, the yth element, and that's it. That's it. As simple as that. All right, so let's check the pre-test passed, and the main test already passed. So thank you.